Hello everyone, in today's video we are going to explore how to test the listening abilities of AI models like ChatGPT. Specifically, we will look at deductive, abductive and inductive listening. And I'm going to show you how we can challenge these models with real-world examples to see how well they can think logically and listen to different situations. So let's dive in and see how well AI can handle these three types of listening. The first one is deduction. So deductive listening is when we take a general rule to apply to a specific case. If the premises are true, the conclusion must also be true. It's like a math equation. Everything fits if the rules are right. For example, I test this with LLM. The question is, if all financial markets are efficient and the stock market in country X is a financial market, can we conclude that the stock market in country X is efficient? This looks logical at first, but the issue is that the premise that all financial markets are efficient isn't true in real world. Some markets have inefficiencies due to factors like regulation or insider trading. I asked LLM and it correctly pointed out that we cannot assume all markets are efficient. So the conclusion doesn't automatically follow. The next question, I try a longer through functional questions. The question is, if all hospitals in country A require patients to undergo a COVID-19 test before being admitted, and John is admitted to a hospital in country A, can we conclude that John had a COVID-19 test? It seems straightforward, but I want to see if the LLM would consider possible exceptions like emergency admissions where the policy might not be followed. The LLM recognized that while the argument is valid, there could be exceptions which made the listening more nuanced. So now let's go to abduction. This type of listening is about forming the best explanation based on incomplete information. You don't have all the facts, but you could try to make the most possible guess. For example, I asked the LLM, a patient presents with fever, sore throat, and swollen lymph nodes. Given these symptoms, what is the most likely diagnosis? These symptoms could point a few different conditions like strep throat, mono, or the flu. The LLM made a reasonable guess and said mononucleosis or mono was the most likely diagnosis, but it also pointed out that it couldn't be 100% certain without more tests. That's a good example of abductive listening. The LLM picked the most likely explanation even though there's always some uncertainty. And the next, I try a legal abduction scenario. The question is, a company is being sued for negligence after an accident. The company says that they follow safety protocols, but no direct evidence exists to support this. Based on this, what is the most plausible explanation for the accident? So in this case, the LLM suggests that the safety protocols might not have been followed properly, which seems like a reasonable explanation based on the lack of evidence. This is another example of abduction where the LLM inferred the most likely cause from the limited evidence available. Now the last one, induction. Inductive listening is when we generalize from specific observations to make broader conclusions. It's about spotting patterns and predicting what might happen next. But remember, the conclusion is always probable but not certain. So, I test the LLM with this question. Every time I heat up this metal, it expands. Can I conclude that all metals will expand when heated? The LLM correctly points out that while this specific metal expands when heated, we cannot automatically assume that all metals will behave in the same way. Some metals might contract when heated, so the model didn't overgeneralize. This is a great example of inductive reasoning, where we are making a reasonable generalization, but the conclusion isn't guaranteed. Then another example, it is a scientific induction. The question is, in a study, 80% of patients who were given drug A reported a significant reduction in symptoms. Can we conclude that drug A is effective for all patients with his condition? So the LLM correctly said that while 80% is strong result, we cannot conclude that drug A will work for every patient. This could be individual variation or side effects that are not captured in the study. So the LLM recognized that inductive reasoning works with probabilities, but we need more data to confirm a universal conclusion. So in conclusion, to wrap up, we have covered deductive, abductive, and inductive reasoning and test how the LLM handle each one. Deductive reasoning applies general rules to specific cases, but we need to make sure the premises are sound. And abductive reasoning make the best guess based on limited information, but it always leaves room for doubt. And inductive reasoning generalize from specific observation, but we need to be careful about overgeneralization. By testing these reasoning types, we can see how well LLMs can handle real-world complexities, uncertainties, and exceptions. This test help us to understand how the model can reason logically and deal with the situation where the truth isn't always black and white. Alright, thanks for watching.